a couple of days. I hope everybody can hear me clearly. I'm waiting a headset ordered from Amazon. Hopefully they won't shut it down before they send it out to me. But anyway, DHCP v4, all right? Should be able to explain how DHCP v4 operates in a small or medium-sized business network. DHCP v4 operates pretty much the same in any size network, okay? You can configure a router as a DHCP v4 server, which you've already done, and configure a router as a DHCP v4 client, which you have not done as yet. Do note that the larger the organization, the less likely your server, your router will be configured as a client. All right. Let me see something here. Somebody's iPhone over here, and it won't take the. There it is. You know something? I got to do something because you know how I am with those transitions. Drive me crazy. They take too long.
Got to get the transitions just right.
Yeah, right. There we go. So, perfect. The concepts. ACP assigns IPv4. I got Alejandro's phone is like stuck on the top of my screen. Here we go.
It's what?
Stuck on the top of my screen. That's okay. I got it fixed. Get out of the way. Assigns DHCP-v4. Now, realize DHCP-v4, and we'll also be covering DHCP-v6. All right? So DHCP-v4 assigns IPv4 addresses, as well as all kinds of other network configuration information dynamically. Now, realize that there are a couple of different ways to do it with DHCP. You can do static reservation. You can do dynamic. All right? There are a number of ways to do it. And not only addressing information, utilizing DHCP options allows you to assign additional information. Like for VoIP phones, you may have to assign a TFTP server address as well as a profile for the phone to pull so it knows its identity. So realize there are a lot of different options that can be used with DHCP-v4 as well as DHCP-v6, all right? Because desktop clients typically make up the bulk of network nodes, DHCP-4 is extremely useful and time-saving, as well as almost error-free for assigning basic addressing to devices. A dedicated DHCP-v4 server is scalable, relatively easy to manage in small branch or SOHO locations. A Cisco router can be configured to provide DHCP-v4 services without the need for a dedicated box server. You know, like you have a web server, right? Typically, DHCP in larger organizations is handled on a server, a dedicated blade server or box somewhere that's configured, and then requests are relayed to the server from the segment, okay? Cisco routers can be configured to provide DHCP-v4 services without a dedicated server. The iOS software supports an optional, full-featured DHCP-v4 server. That means you can assign addresses dynamically, statically, however you need to do it. The server dynamically assigns or leases for a period of time that you can configure an IPv4 address from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. The client leases info from the server for an administratively defined period. That means you configure it. Administrators configure the servers to set the leases to time out at different intervals. The lease, typically anywhere from 24 hours to a week or more. It can even be infinite. More likely, when you deal with DHCP-v6, it will be an infinite lease because there are so many DHCP-v6 addresses, we don't care. When the lease expires, the client has to ask for another address. Now, what happens when the lease expires, okay? The server reclaims the address. It's not like it expires on the host and the host says, oh, I have to get another address. No, the server expires the address and reclaims it from the host, okay? Then the host will request a new address and it'll be assigned another address. Typically, you know, it can be the same address, but depending on the instance, a lot of providers, or should I say, DHCP servers are configured not to give the same exact address again. This way you can't run any servers on that client. Because if you always get the same address, you can run a server from that client. So typically providers will configure DHCP so that you can't get the same address. It's always a different address. DHCP v4 works in a client server mode. When a client communicates with the DHCP v4 server, the server assigns or leases the address to the client. Client connects to the network with the leased IPv4 address until the lease expires. Client has to then contact the DHCP server periodically to extend the lease. Lease mechanism ensures clients that move or power off don't keep the address they no longer need. When a lease expires, the DHCP server returns the address to the pool where it can be reallocated as necessary. It's a 4-step process. It's actually 5 if you include the negative acknowledgement, okay? When a client boots up or wants to join a network, let's say, begins the 4-step process to get a lease. The host boots up. It sends out a DHCP Discover broadcast. Any available DHCP v4 server on the segment that sees that broadcast can respond. Multiple servers may respond, okay? The servers respond with the DHCP offer. That's unicast back to the host's MAC address because it doesn't have an IP address. It's to the MAC address of the host. Now realize this process is somewhat different if the DHCP v4 server is not on the same LAN segment, that means layer 2 LAN segment, as the host. If you're relaying the DHCP Discover to another segment, it's a slightly different process, okay? So the DHCP v4 offer generally contains the address, subnet mask, default gateway, DNS servers, any DHCP options configured, like if you're running it to a phone or something. The host receives the DHCP offer and then sends out a DHCP request, which is broadcast again because the host cannot use the address information received from the server at step 3. It can only use that information once it receives a DHCP acknowledgement, unicast back to its MAC address. Now, if the host takes too long to respond to the DHCP offer with the DHCP request to lock the information, then the server may send back a DHCP NAC, which is a negative acknowledgement, okay? Typically, it's an acknowledgement, DHCP ACK. That means, your acceptance is acknowledged, the information is locked in, and you can now use the addressing information. But if you get a NAC, negative acknowledgement, you have to start all over again with the DHCP Discover broadcast, okay? Prior to lease expiration, the client begins a 2-step process to renew the lease with the DHCP v4 server as shown in the figure. You send a DHCP request before the lease expires. Client sends the request message directly to the DHCP v4 server that originally offered the IPv4 address. Now realize that in larger networks, you have more than one DHCP server. The DHCP servers replicate to each other so that they know what addresses in a given block are assignable and which are already assigned, okay? So they have to replicate between each other. The DHCP request is sent to the DHCP v4 server that originally offered the IPv4 address. If an ACK is not received in a specified amount of time, client broadcasts another DHCP request so one of the other DHCP v4 servers can extend the lease, and then they would replicate across each other for that process. The acknowledgement on receiving the DHCP request, server verifies the lease by returning an ACK. Messages primarily, the DHCP offer and DHCP ACK can be sent as unicast or broadcast according to the IETF 2131 RFC, request for comments. To configure the iOS as a DHCP v4 server. Maybe I should hold and have you guys explain this to me because I know you've already done it, but we'll keep rolling along just so I can keep you amused for a while. So now that you have a basic understanding of how DHCP v4 works and how it can make your job easier, because really, you have a site that has 300 computers. Imagine going to every single computer and having to open up the network control panel, put in an IP address, subnet mask, default gateway, 2 DNS servers, next host, open the control panel, address, mask, gateway, DNS servers. That is error prone. Okay, after about the 10th or 15th host, you're probably a little messed up behind it. Anyway, Cisco router running the iOS software can be configured to act as the DHCP server. The iOS DHCP v4 server assigns and manages addresses from specified address pools within the router to the DHCP v4 clients. Now, you already know the commands to set up a pool in a router for this given scenario on the screen. Realize you have two separate networks here, so that would be two separate DHCP pools. There would be a pool for the 10.0.24 and a pool for the 11.0.24. And essentially, the commands are very simple. For the 10.0 segment, you would put IP DHCP pool LAN 10. Press enter. Type network 192.168.10.0 space 255.255.255.0. Press enter. Then type default dash router 192.168.10.1. Now realize that 10.1 is the address that's going to be serving the DHCP addresses for that segment. So you have to exclude that address from the pool. Now you can do this before or after you create the pool, but you must do it. Otherwise, you're going to get addressing conflicts because the server will try to give out that address. Now, once upon a time in Cisco routers, you didn't have to exclude the gateway because it was built into the operating system not to distribute the gateway address. And then at some point, that made it out of the operating system. At any rate, the command to exclude that address is IP DHCP excluded dash address 192.168.10.1. Now that segment is fully set to go. The other side, you would do like IP DHCP pool LAN 11 network 192.168.11.0 255.255.255.0 default dash router 192.168.11.1 and then IP DHCP excluded dash address 192.168.11.0. Everything I just told you is right here. So just read this screen. Note the prompt, okay? Now, more often than not, when you're in global configuration mode, it's config dash whatever, okay? There are one or two modes where it prefaces the config, like configuring DHCP is DHCP dash config, not config dash DHCP. So keep that in mind, all right? Okay. Yeah, now another note back on this slide. When you need to exclude addresses, you can exclude a range of addresses. Like think about this. If you have a set of printers on a floor, you might have them addressed in a specific range, which is what most organizations do. It's like, you'll have a range of 40 to 50, and those are your printers. So you would use the command IP DHCP excluded dash address, the low address, and then the high address. So you can exclude an entire range, but they must be contiguous. In other words, from 40 to 50. And then if you had another address like the gateway to exclude from that pool, you can do that on a separate line. Okay, but there's no putting commas and, this address, comma, that address. Individual addresses are done on separate lines. A range of addresses are done on the same line by listing excluded address low to excluded address high. Okay? Step 3, define the pool. There you see the commands for that, everything I just told you. If you needed to set the lease. Now do note, typically, on end user stations, an address without DNS servers is useless because you're going to open your browser and type in www.dumbstuff.com. If you don't have a DNS server address to resolve that alpha address to numeric equivalent, then you won't be able to get to dumbstuff.com unless you know the exact IP address. Most hosts also require the domain they reside on. So you would list the domain name, okay? And then you can configure the lease in days, hours, minutes, or you can tell it it's infinite. Keep it forever until you'll move to another segment. You can also list NetBIOS name servers as well as various options, like option 150. So you can set a TFTP server address and TFTP file name for a VoIP phone to get its identity. This is a basic configuration for what I just told you. Okay. The only thing I didn't include when I stated it was the DNS server and domain name. Okay. So do note that on a production network, you would absolutely have DNS server and domain name listed with your DHCP configuration. To verify it, show running config pipe section DHCP will show you the commands configured on the device. You can type show IP DHCP binding to see the MAC addresses and what IP address is assigned to that MAC address, and show IP DHCP server statistics to display count information regarding the number of DHCP v4 messages sent and received. Verify DHCP v4 configuration. Do note, if the DHCP service is not running, then you have no DHCP. So you can always type show running config pipe include service DHCP. If you don't see that, then DHCP isn't running. Again, there are additional commands. This is your section to see that it's configured, but you have to make sure that the DHCP service itself is running also on the device. Show IP DHCP binding shows you here how the address was allocated, the current state, the address allocated, and the MAC address it was allocated to. Now, do note, one thing we don't discuss typically in CCNA and whatnot is that you can actually ping and trace MAC addresses, but you have to enable another service to do that, okay? We typically cover that in like a CCNP class, but this will show you all of the addresses that the DHCP server assigned. Verify the statistics. There you see the memory usage, how many packets, how many address pools you got, how many bindings are currently in place, and how many messages were sent and received. To verify that a client received an address, you know how to do that. Open up a DOS dialog, click on Start, go to Run, type CMD to open up a DOS dialog, then type ipconfig/all. Show you everything you need to know, your DNS servers, your DHCP server, your default gateway, the lease time, MAC address, everything, okay? Now, ipconfig/all will show you everything for every interface. Now, in your computer, even a laptop, you have multiple interfaces. You have tunnel interfaces and all kinds of stuff. So realize you'll see multiple sections. Not all of them will have addresses because not all of them are using DHCP. Service, you can type no service DHCP. That will disable DHCP in global config. Okay, to re-enable it, type service DHCP. All right. Now, clearing the bindings, stopping and restarting DHCP probably will result in duplicate addresses being temporarily assigned on the network, but they will resolve as they appear in conflict and then are removed from the host. Okay? In a complex network, do note that the router is the ultimate broadcast firewall. Okay? That simply means that anything received on one layer 3 interface on a router is not forwarded beyond that interface. So broadcasts are local to the segment, the LAN segment, the layer 2 network, bound by the layer 3 interface on the routing device. You can, if let's say your DHCP v4 server, if you look at the picture, you see PC1 is looking for a DHCP v4 server. However, the router is not configured to do DHCP. In this case, it's a dedicated server that's at the address 192.168.11.6. Okay? Now, when that host boots up, he's going to send out his DHCP request. All right? G000 on R1 will pick up that broadcast. Now, in order for that G000 interface to send the broadcast to the DHCPV4 server on the 11.0 segment, the interface has to be configured with an IP helper address. Okay, the IP helper address allows you to send it to a segment where you may have multiple DHCPV4 servers. It also allows you to send it to a specific address on a given segment that may not be attached locally. So like in this example, you'll see that the DHCPV4 server is attached on G001. It doesn't have to be there. That server can be elsewhere, 2 or 3, 4, 5 hops away, and it will still work as long as the DHCP requests and offers are transmitted in a timely fashion, okay? So on G00, the command would be IP helper-address 192.168.11.6. Now, what happens when you do that is the router takes that DHCP Discover broadcast, rewraps it in a unicast packet, and then forwards it unicast to 11.6. Now, when the router is doing relay like that, using a helper address, it inserts the gateway interface address, because you might wonder, okay, a server on 11.6 or the 11.0 network, how would it know what address to send back? Well, the router that receives the DHCP Discover broadcast on G000 will encode into that forwarded unicast DHCP Discover. It will, let's see, something happened here. Okay, nothing. You guys can hear me, right? Let me see here.
Yes, we can hear you.
Yes.
All right,
Yes.
good deal. Because it got kind of quiet. It's never that quiet in class. You're freaking me out here.
We have our microphones on mute.
Oh, okay.
Yeah, we can hear you.
I thought I was talking to myself here for a minute. All right, back to work.
All right.
So as you understand here, that G000 interface will encode that packet, the DHCP Discover broadcast, into a unicast packet so that it can route it to the 11.6 server. Now, when it does rewrap it in unicast, in the DHCP request, it fills in the GIA address, the gateway interface address, with the 192.168.10.1 that's hard-coded on G000. This way, when the server receives it and unwraps the DHCP request, Discover, it knows which pool to look for an address in. Does that make sense? Yeah, I would imagine it does. So, if you configure R1 with the IP helper-address and then the specific address interface config command, this causes R1 to relay the DHCPV4 broadcast to the DHCPV4 server. As shown in the example, when you look down here, you got int G000. Now, do realize if you show IP int G000, it is configured, the 3 commands on the left side of the screen, int G000, IP helper-address 192.168.11.6, and then you type N. Well, do note that G000 interface does have an address configured on it. So that's only the helper address command that you're seeing there for the DHCP. All right? Now, when you type show IP int G000, you'll see the helper address. That is the address that the DHCP Discover broadcasts are being relayed to. Now, the reason I say relay is because when we start talking about DHCPV6, for IPv6, it's traffic relay is the command, not helper address. IPv4, it's helper-address, okay? When we get to IPv6, we'll go over it there. DHCPV4, not the only service the router can be configured to relay. By default, the IP helper address command forwards the following 8 UDP services. You got port 37 is time. Port 49, terminal access control server, TACACS. That's for AAA, in case you needed to know. You got port 53 for DNS. port 67 for, and 68 for DHCP. Port 69 for TFTP, 137 for NetBIOS name service, and 138 for NetBIOS datagram services. So these are additional services that can be forwarded from one segment to another. Okay? Does anybody have any questions? Or do I got to click something to get you to get questions?
So I just had a question about the helper address command exactly. If you could explain that a little better.
The helper address
Yeah.
allows, okay, the helper address. When you have a router interface that you configured, right? Let's go back to the diagram. All right. If you look at that router, R1, okay, layer 3 interface G0/0/0, configured with 192.168.10.1. See the one, right? That interface, now layer 3 interfaces on a router will not, by default, will never forward a broadcast to another segment. So any broadcast on that G000 segment can never get to G001 without additional configuration. Does that make sense? So the helper address command allows you to specify where to forward a broadcast to specifically, because a broadcast received on one interface can only be sent out another interface, unicast. Makes sense. Because you can't take a broadcast from one segment and put it as broadcast on another segment. It would have to be rewrapped as unicast and sent directly to a unicast address. Now, there is a way that you can take a broadcast and forward it as a broadcast on another segment. Like supposing you had multiple DHCP v4 servers on that segment. You could specify the destination segment network to forward to. This way, any server on that segment can respond. Does that make sense? But that's going to be very restricted in the way that you configure it. This way, we're just taking the broadcast from one segment and sending it unicast directly to the server for processing. Because routers never forward broadcasts by default. Does that make sense?
Yes, I understand.
See, like if you see over here on the G001 segment on the slide, you see PC2? If PC2 sends out a broadcast, both servers will see it and the router interface will see it. Okay? PC1 on the other side, the G000 side, if he sends out a broadcast, since he's the only node there, the only interface that's going to see it is the G000. It'll never go to the other side. It'll never make it to a DHCP server because it was a broadcast.
Okay, okay, all right.
Routers don't forward broadcasts. You put the IP helper address command on G000, it'll now accept that broadcast, rewrap it unicast, encode the 192.168.10.1, which is the G000 interface IP address. It will encode that in the GIA section of the DHCP request so that when the server on a totally different network that's serving DHCP sees that packet, receives it via unicast, it will open it up and see the GIA address so it knows which pool to pull an address from, because the server probably has multiple pools configured on it. So if there's no GIA address in there, then it knows it's my same segment. So it looks for 11.0 pool. But if it's encoded with the GIA address of G000, then it looks for a pool for the 10.0 segment. That's how it distinguishes which pool to pull an address from. Does that make sense?
Yes.
Okay, so the helper address is only so that you can forward certain types of packets that would not ordinarily be forwarded to another segment, like broadcast packets specifically. A broadcast on G000 can never be seen by G001. A broadcast on G001 can never be seen on the G000 network. You have to configure it to relay the broadcast.
And is that where you were mentioning the ports? Because the type of broadcast you're going to want
Yes,
to forward is
absolutely. There are multiple services that require broadcasting, and in order to forward a broadcast, now realize standard TFTP, you don't have to worry about that. It's typically not broadcast. However, have you ever booted up a router that didn't have a config but did have cables attached to it? And you see that it says it's broadcasting for a TFTP server. Come on now, I know you've seen it. Must have seen it. Where it gets hung looking for a TFTP server because it doesn't have a startup config. Well, if you didn't see it, as soon as we get face to face, I'm going to show it to you. Somebody remind me. Take a note.
Okay.
Is if a router boots up and it has cables connected to other devices and there are active links, okay, if it doesn't have a startup config, it will begin broadcasting for a TFTP server looking for a specifically configured startup config file name. All right, you can configure this in routers, they'll look for a specific file. Now, if it's broadcasting, any other layer 3 segment is not going to accept it because the broadcast, it's going to get cut off at the layer 3 interface of the next directly connected device. So in order for that device to be able to forward to a TFTP server so that the router that does not have a startup config can see if that TFTP server has a startup config for it, you would have to configure that interface with the helper address, and it would have to be forwarding TFTP port 69. Does that make any sense? I guess you would have to see.
This makes sense.
See it actually happen on a router when it boots up and it doesn't have a startup config.
Yeah.
Which is a little difficult. I mean, I don't think that Packet Tracer would do it, but I know for a fact if you have GNS3, GNS3 will do it. But GNS3 has its own learning curve. It's a little problematic in that respect. All right. Trust me, I'm sure we'll be back in school before long. The way they're talking about they have cures. Anyway, so the other services do have some broadcast capabilities that these services right here, like you know that DHCP is broadcast, right? You know what I mean?
Mm-hmm.
So the initial startup conversation for DHCP is the client broadcasts a DHCP Discover. That's broadcast to 255.255.255.255, as well as FFFFF, you know, the broadcast MAC address, okay? Now, TFTP, like I said, if a device doesn't have a startup config, a router, it will attempt to broadcast if it has active links. Even though it doesn't have any IP addresses or configuration, it will attempt to broadcast to locate a TFTP server, and then it will ask for a specific file. All right? The same thing with NetBIOS. NetBIOS is more like a local type thing, layer 2 anyway. So, you know, for that, if you want it to get from one segment to another segment, when I say segment, I mean layer 3 interface to another layer 3 interface, you have to configure that layer 3 interface receiving to forward it. And that's done using the IP helper address command. Does that help a little bit?
Okay.
Okay, no okay? We good? Sort of?
Yeah.
As good as ever, really.
As good as it can be. Now look, you have Packet Tracer, all right? You guys all have the Packet Tracer files from your account, right?
Mm-hmm.
Why don't you take like a half hour and do that Packet Tracer? What time is it? 10:44? Yeah, you should be able to, everybody got Packet Tracer installed on their computer, right?
Mm-hmm.
I
Yeah.
don't even think I have it on mine, to tell you the truth, but If you have to, log in, download it, install the latest version. You'll need that for the exams and everything. And do this packet tracer activity, configure a DHCP v4 server. Now, I know you've done this in class on the actual hardware, but trust me, practice makes perfect. And, you know, since we can't access actual hardware, well, I mean, let me not say that because I have hardware here. But since you guys can't access actual hardware, work the packet tracer. The primary difference between packet tracer and the actual routers and switches, okay, is one, you're dragging and dropping cables in packet tracer. With the actual equipment, you're actually plugging it in. I consider that an important part of the learning curve, but as long as you understand that when you drag and drop a link, a wire on G000, that's the same as plugging an Ethernet cable into G000. You know what I mean? In addition to that, packet tracer is a simulator. The hardware is the actual real world stuff. So there may be slight differences in terms of how they behave. Overall, though, packet tracer is an outstanding tool. And trust me, when you see the hands-on finals coming your way, you're going to understand that, yeah, packet tracer actually does have the capabilities necessary. Okay, because the hands-on finals aren't easy. Not at this point. All right, so take a half hour and work that lab. But please work it. I know you're going to walk around. I know some of you got kids running around your house right now acting crazy and everything. But take a little bit of time and try to work that lab.
So,
all right, then we'll come back and we can discuss it.
what lab is that? What lab number is that?
It's going to be, this is 7, and it should be 7.
7.2.10.
Yep, that's going to be it.
Okay.
Configure a DHCP v4. Now, what you're doing here is you're going to be configuring it for DHCP relay, which is how it would be done in a larger enterprise network. You'll also be configuring a router as a DHCP client. This would be done in smaller networks, all right, as well as a DHCP server. So you'll have the DHCP server, one router providing an address to another router that's acting as a DHCP client. Now, if you're wondering what that scenario would be, think about it like this. You have your home router, right? When you boot up, your home router requests a DHCP address from the service provider. Service provider gives you an address, DNS servers, domain name, and then that router provides DHCP internally to your hosts on your wireless or wired network. Get it? And then the DHCP relay is more like a corporate size network configuration. So this is actually a good lab to do. All right? Take about a half hour. If you need more time than that, we're fine. This is day 1, back at work. I usually don't work very hard my first day back at work. So I don't expect much from you guys other than get used to how we're going to, proceed with this model. Sound good?
Okay.
Sounds good.
All right, so I'm going to put you guys back on video. If you got something, holler out if you need to know something, all right? I should look and see how many people stayed in. Where is it? I only see how many people were there.
15 people are in?
15?
Yeah, somewhere around that.
All right, good deal. All right, so I'm here, work the lab. Just like in class, once I do my thing, you guys do your thing. All right?
All right.
So work this lab and then we'll continue with the presentation. Today's going to be a slow day. All right? I ain't going to hurt you. Where is it? Bake break. And I'm here. I didn't go anywhere. I just went off camera so I could bake. I wouldn't want them to say that I'm corrupting you guys. And girls. Remember, anybody that needs help, give me a holler. I'm gonna take this off share screen for a while.
All right.
So anybody that needs help, just give a holler.
All right.
You know, I was gonna get a video, little audio from The Purge and start the meeting with that.
The Purge.
Yeah, the sound they play when The Purge starts.
Oh my God, you're horrible. You're horrible. The alarm. That's funny.
But I was afraid Jennifer would come in while I was doing it.
The excluded IP4 addresses. Addresses have been statically assigned to devices in the network that use DC.
All I can say is think of how many jobs there's gonna be. I know that's mean, but I think if you're like 70 years old, you should like retire. Give up that job for the next generation. Now, I don't know if there's any of these alerts and speeches by the mayor, the governor, or the president. If you need to stop and, you know, like listen to that, just mute and go watch what you got to watch. Okay. I'm sure there are some people that need some help with this or that, and you need to hear these things these people are saying. This is important. And we can accommodate that. I mean, we can go until 5:30, but then I got another class at 6 o'clock. So I'm good. I'm here all day. I ain't going nowhere. Got nothing to do. Got plenty of food, plenty of toilet paper. I'm good.
Jeez, so you're doing all of your classes like this?
Yeah.
Oh, rough. I mean, hey, what can you do?
It's gotta be.
Yeah, that's rough.
World can't stop. Now think about this, okay? Think about the field that you chose, the classes that you chose to be part of. Do you think any of what we're doing would be possible without people like you?
Not at all.
Not a damn bit of it. So understand, you made a good choice. It's the right choice. That's the way the world's going to go eventually.
Word. I'm glad I'm not in the hospital. I used to work in the healthcare industry. I'm glad I'm not in the ER anymore.
Yeah, man. Shoot, you'd be in a freaking bed with a respirator down your throat.
My friends are in the ER are going through like the worst, and the hospital is actually expecting them to report to work even if they test positive.
That's like so wrong, it ain't even funny.
My friend had to argue for them to let her go home for 72 hours.
Really? That's insane. I got to pull up that text box, the chat. There it is. There you go. Now, for John Seaman, are you in again? Your PC froze. I thought you were a tech. That shouldn't happen. That's good to hear she's in full gear. All right. So let me just answer a couple of these questions that I didn't see because I had the video going. So I'm going to scroll back and I'll go forward. You know, when I go to presentation mode, it's kind of hard to see everything with the chat box and everything going. I'm answering questions in chat as I see them, okay? What is that? What am I hearing? A drug deal going on in the background?
Oh, sounds like it.
Ah, I'm just kidding. I was gonna say, if it's skunk weed, let a brother know. Kidding. For those of you that are recording, I'm just joking.
No worries, the
Disclaimer,
recording is
disclaimer.
paused.
Oh no, Gene, you actually went ahead with it. I hope you have enough hard drive space for all of this.
Right?
I bought an external hard drive like 2 days ago specifically for this purpose.
Oh shit, he's prepped for you, man.
You
Stop. Take a little bit. Feed me. Look, I got my girl feeding me. Mm. She operates a knock. They knew about the earthquake in Utah before anybody else. Because everybody went down. So what we're gonna do, we'll take, standard breaks and a lunch from like 12-ish till 1, okay? So as soon as you guys are done with this packet tracer, let me know. We'll look at the time. We'll figure out if it makes sense to do lunch. You got like 15, 20 minutes in the morning, an hour for lunch, 15, 20 minutes at some point in the afternoon, and we'll work it out.
All right.
And also note, you can send me email with, like specific questions if you have additional questions outside of this. But if you're asking questions in the chat, I'll answer them as I see them, okay? The chat screen's not always up on mine because I can't see the screen with it there. All right? With that juice. Got barley? Good beans. And do note, anybody that doesn't have enough food on hand, right? Hope you can all hear me. You need to contact Jennifer and find out if the college food pantry is open. Okay, see whatever help you can get from there if you don't have food on hand. Don't leave yourself short. Keep you and your kids and your family fed. And in case you're wondering why you're looking at the top of my head, 'cause I'm hungry, man. I just woke up. And for those of you that were curious, I know I said that if I had ever had to do video chat, I got pants on, okay? See?
Oh, gosh.
I'm dressed.
Thank you.
Just thought I'd let you know in case you were wondering.
I was doing my very best to not wonder.
And for those of you that are wondering, one of the updates on this is the government's going to kick back $1,000 per adult in a family, $500 per child. So a family of 4 gets $3,000. I think it's going to be a month until this is over. That definitely can't hurt. So you might want to listen to that presidential address. This way you know what you can expect to be coming your way.
Hmm. That's no good.